Alright, our next problem is 25-21. And so this is another net present value problem, except this one has an unequal lifespan. So we have Bunker Hill Mining Company has two competing proposals. We have a processing mill and an electric shovel. Both of these pieces of equipment have an initial investment of $750,000. And for the cash flow, so the processing mill is going to go on for 8 years, and the electric shovel is going to go on for 4 years. And so it also tells us that the residual value for the processing at end of year 4, so right here, is $280,000. And so we need to figure out, based on a 15% minimum return, what's the best choice. And so whenever you're comparing investments with unequal lives, what we want to do is we want to make them equal. That way we're comparing apples to apples. And so the reason we don't want to compare them with unequal lives is that if we come up with a value for the processing mill, because it goes out further, chances are it's going to have more cash flows, or the present value of the cash flows will be greater. The problem is that with this electric shovel investment, at the end of year 4, our cash is going to be freed up. And so what we want to do is we either want to cut this investment off at the 4-year point, or we want to assume that, say, hey, at year 4, we're going to get all our investment's going to be done, but we're going to have all of these cash flows back that we can turn around and take our money and invest it maybe in treasuries or something else to get us out to 8 years. So the key with this is just, for time period purposes, try to have the same number of years. So we'll start off on this one by calculating our present value factor. And so we'll use the present value function in Excel, and we're going to start off with the round function just so it matches our book number. So do present value, and so the rate is going to be 15%, and the number of periods is going to be this cell, which is, let's see, it's cell M6, and no payments. And since we're doing our present value factor, we're going to use a -1, and we want to round this to 3 digits. Alright, so that gives us our present value factor for each year. And so now we want to figure out the present value of the processing mill. So if we just take our present value factor, multiply it times the cash flow, and same with the electric shovel, take our present value factor, multiply it times our cash flow. And so what we did here is, since it told us that we have a residual value of the processing mill at the end of year 4, we're going to assume we're going to cut off our evaluation at the end of the 4th year. So that includes the cash flows at the end of year 4, plus we're going to turn around and we're going to sell this processing mill for $280,000. So the present value of the processing mill's cash flows is $196,220, and the present value of the electric shovel is going to be $179,690. So at the end of year 4, it looks like we would be better off cash flow wise to go with the processing mill. Alright, so our last problem is problem 25-4A. And so this one is going to be a little bit of everything. We're going to figure out our net present value, our internal rate of return, to see what investment is better. Do we want to invest in this wind turbine or the biofuel equipment? So we have management of advanced alternative powers considering 2 capital investment projects. We have a wind turbine and a biofuel. And so over 4 years, we have the cash flow. So this is going to be $280,000 every year. The biofuel is going to be $300,000 every year. The wind turbine is going to have an initial investment of $887,000, while the biofuel requires an initial investment of $911,000. And so let's go ahead and finish filling out our table here. So we want to start off by calculating our present value factor, which we're going to start off with the round function and then the present value function. And so our rate, let's see, it tells us that to use a rate of 6%, so 0.06. And our time period is going to be in cell M5. Okay, no payments since we're doing just calculating the factor. And then our future value, -$1. And we want to round that to 3 digits. So now we have our present value for each one of the years here. And so now we want to calculate the present value of the cash flows. So that's going to, for the wind turbine, we have the cash flow times the present value factor. And so we can drag our formula. We're going to lock down part of our formula here. And now we can just drag that over. So now we have our table set up. And so the first one, it says we want to calculate the net present value of each one of these investments. And so the present value of the cash flows from the, actually, let me back up. Since we're going to do this in 2 steps, I'm going to remove our initial investment cash flows. Looks like our formula only grabs there anyway, so we're okay. So for the wind turbine, we want the value of the cash flows, which is the $970. And for the biofuel, the value of the cash flows is $1,039,000. And then we want to plug in our investment. So the investment for the wind turbine is $887, and the investment for the biofuel is $911. So the net present value of each one of these 2 projects, so the value of the wind turbine is $82,600. The net present value of the biofuel equipment is $128,000. So based on this analysis, it looks like the biofuel is the better investment. All right, and so part B, we want to calculate a present value index to 2 decimal places. And so that is going to be the total present value of the net cash flows, and we're going to divide that by the investment. And so the total present value of the cash flows for the wind turbine is $970. The investment is $887. Gives us present value index of 1.09. And for the biofuel, The present value of the net cash flows is the 1,039,039 divided by the investment of 911 gives us a present value index of 1.14. So this is just another analysis. The better index you have, the better. So this is just another evaluation that says that the biofuel investment is better. So the next tool is the internal rate of return. And so we could calculate this based on the formula where we take the investment divided by the cash flows and then find a table and try to match up the number. But a much easier way to do it is just use the internal rate of return function. So for the wind turbine, we just grab our cash flows and let's take a guess on the rate. I usually use 10%. Returns us with a value of 10% return. And for the biofuel, we grab the cash flows from the biofuel. And so when we do the IRR, remember we actually do grab that cash flow 0 of the initial investment. Let's just use 10% again for our guess. Gets us to be 12%. So the internal rate of return on the wind turbine is 10%. Internal rate of return on the biofuel is 12%. So again, biofuel tends to be the better investment. However, if we're looking back here, it says, hey, if we want a minimum rate of 6%, both of these are good investments. None of these lose money based on our 6% rate. So the wind turbine is returning a 10%, so that's better than our 6%, and the biofuel is returning 12%, which is double. So both are good investments. It just happens to be that the biofuel investment looks to be the better way to go. So that looks like it's it for chapter 25.